So I'm joined by a very special guest, Johannes Peeters. Is that right? Tell me how to pronounce your name.
That's right. That's correct. I'll go with that.
And you're joining us live from Belgium, I gather. Is that right?
That's right. Yes, we're live from Brussels, where we are headquartered.
Wonderful. Excellent. And you're with Voxel Sensors. Is that right?
That's right. Yes, you got that right.
Excellent. Well, I'm so glad you joined us, and I really appreciate your time because I know you're very, very busy. We've been following some of your news over the past 6 months, I think, and my gut just told me as soon as I saw this, there's this low power, there's this low latency, there's a very novel approach to the technology. And again, it's almost like I hear this voice in my ear saying, this is going to be big. Obviously, full disclaimer, editorially, I'm objective, I don't know. I just have a sense this is fascinating. And I'd love if you could just tell us briefly, what is your novel technology and how are you starting to apply it?
Thanks for the intro. Let's see from which angle I take it. I think from the application side, it's probably the easiest. We have our friends at Apple that recently announced the Apple Vision Pro spatial computing device. They don't call it an AR or an MR device. And that's all about representing yourself into a 3D world. They even call it a 3D camera somewhere on their website. And in order to represent yourself into a 3D world, you need to sense the world. And in order to sense the world in a very efficient way, you need the right technology. What you see in existing devices, in any technology that is out there today, it's technology that's typically seeing the world in sequential frames, as we call it. The way we take our video call here, it's 25 frames a second. The image is refreshing, and we get all the new information that is coming in. But that is not very efficient. If you want to be really efficient, everything that is irrelevant, you wanna take out of that continuous refresh. That doesn't even matter. And so in the 2D sensing, in the color space, activities have been going on to get there. In the 3D sensing, that's where we operate, not so much. And so all the existing 3D sensing technologies that are out there are energy inefficient. They consume quite a bit of energy, into the hundreds of milliwatts. And they consume, or they have quite a long latency. And latency is the delay between something happening in the world, perceiving it by your sensors, and having that information available for processing. And we see hundreds of milliseconds of power consumption and tens of milliseconds easily of delay, of latency.
And just as a note for our audience, I recently was at the Detroit A3 Automate show, and we were chatting with some folks about how the factory floors are using this spatial technology now, and it's a physical safety issue. Do you want it to be instant, immediate? You want to know, because you've got all these robots flying around, you've got drones flying around, you've got AMRs driving on the floor, and you want them to know immediately if there's a change. So for our audience that isn't as familiar, this is also it's not just an efficiency, it's also a safety issue.
Absolutely. And if you think about, for people that are driving cars, if you think about a car which is running 50 kilometers an hour, so that would be around 35 miles per hour. And if you have the typical LiDAR systems and the emergency braking systems, they take around a couple of hundred of milliseconds to respond, up to even more than half a second. And if you go from half a second of latency before the car starts braking to 5 milliseconds, and that's kind of the latencies we're operating at, you're actually gaining 5 meters of stopping distance. 5 meters being, now I need to think, 15 feet, roughly. And that's time you gain for free if you use the newer technologies. And so 15 feet, 5 meters can make a real difference in hitting someone or killing someone.
We saw a huge display. They built a model factory floor, and they had the autonomous forklifts, right? Zooming around, picking up. And so if you think about it, like you said, 15 feet with an automated forklift, that's quite a distance.
That's quite a distance, yeah. And so what you see in factory floors is either you get this isolation of where the robots operate and the humans operate, or you get robots that are or cobots where they operate in parallel with human beings, but then they operate really slow, or they try to build them with soft materials in order that a soft bump isn't any harmful. But if you really want to pick up speed, if you want to increase the safety over there, the sensing modalities that you're going to use are going to change in the near future.
Now, I'm curious, there's a special name. What do you call your technology?
We call it switching pixels for active event sensing.
Pixels. Now, how are you achieving this fast latency, this low power? And it sounds like it's even more sustainable as well for the climate because it's using less electricity.
It does. And it's I think the big challenge that you have in these kinds of technologies is to operate in environments that are in challenging environments. And what is challenging for technology like 3D sensing is typically the sunlight. The way all those technologies work is they emit a light source, and then the light source is read back in different ways in order to read or measure the distance of the objects in front of the camera. And we've developed something that is extremely efficient in discriminating our active light from any of the noise sources, including sunlight. And if you look at the statistics or the physics of that, with only a handful of photons, which are the elementary light elements, we can discriminate our signal to noise. Where you typically need a couple of hundred of that in other technologies, we do that with a handful in hours. And then the way that's implemented, the way you optimize that whole system, the way you miniaturize that, you fine-tune it for the applications, that comes next, of course. But the fundamental breakthrough is the way we operate our active light versus the sunlight.
What's the gain here? Like, how different is your technology? Is it like 70% better, 50%?
Oh, we've done some comparisons, and I think the most interesting one is the LiDAR technology, which is in here. It's Apple iPhone. That one's consuming around 300 milliwatts at a 33 milliseconds latency, and to do something similar as them, already a bit longer, already in sunlight, so longer range in sunlight, but let's say roughly a similar setup. We do that in less than 10 milliwatts and 2 milliseconds of latency. So it's really factor 15, 10, 15, 20 sometimes difference.
Wow.
It's enormous.
And if you scale that across all the applications globally, that's huge.
That scales, yes. Of course, there's always limitations to any technology. Yeah, we're not in the game of long-range LiDAR, so the 200-300 meters freeway sensing. That's not our game. We don't intend to be there. But anything that is closer, anything that has let's say in the consumer space a range between 0 and 6 to 8 meters roughly, that's really interesting. That's where we play. And in robotics, industrial automation, automotive, anywhere between 0 and 30 meters, that's where our technology really excels.
And this is variable light conditions.
In variable conditions, yeah. So you need, let's think about what you need to solve. You need to solve the power consumption. That's crucial. If you want to get into very small devices, if it's those wearable devices where you want to have a battery that lasts more than 2 hours and that look elegant, like your glasses.
You heard it here, folks. My glasses are elegant.
You need to solve the latency, right? If you have spatial computing devices or augmented reality glasses, a latency anything beyond 10 milliseconds from the moment you capture it to something that is rendered on your glasses is perceived by humans, and so your latency that you have on the sensing side is a few milliseconds to gather the relevant information in the scene. So you need to control latency. Then it needs to operate in pitch black, but also in full sunlight. And you cannot think about a tunnel. When you leave a tunnel, you typically have this reset moment where you're like, oh, this is super bright suddenly. you can't have that in your experience. You can't have, hey, half a second of now you cannot use it because I'm resetting all my systems. No, need to run from pitch black to full sunlight without any disconnects there. And that's also a challenging one in any existing 3D technologies. It needs to support concurrent systems. If you and I are in the same room and we both wear an augmented reality glasses, for example, our glasses shouldn't compete with each other. It should not be because you wear one and I wear one that suddenly our experience is deteriorating because the sensors are competing for the light that they produce. And same with cars, same with robots. And so you need to allow or be compatible with concurrent systems. And those four you need to resolve at the same time, which is the major challenge. Typically in any of the existing technologies, you can pick one, maybe two, and then the rest doesn't work. We're solving all four at the same time.
And again, this is going to be grossly scientifically inaccurate, I'm sure, but in my tiny brain, I'm thinking like the bats use the echolocation. So I'm thinking, okay, my glasses, they're sending out these pings to generate the cloud, point cloud. But for a lot of devices, when I send a ping and he sends a ping, they're going to cancel each other. And you're saying you found a way to make them not cancel each other.
Well, we even found a way that they can enhance each other, which is even better.
You're kidding.
Yeah.
How does that work?
Maybe the very simple principle of our technology is that we're scanning a point in space, a light point, using a laser and some kind of a mechanism that the laser moves around. And then we've built sensors, silicon, that track the tip of that laser beam in the most efficient way. We can track it, we can give a new update every 10 nanoseconds. You can say, hey, the laser points there, as it moves around. And then the technology, or to get to your distance reading, it's a triangulation-based system. So either the way we emit the light and it bounces back into the sensor, or if we want to have a bit more flexibility, we use a light source which is just emitting or scanning the light, and we have two sensors that are picking up the reflection. That forms a triangle. And then we just simply do a triangulation step, or the triangles like that. And then we do a very simple triangulation step to get to the distance reading. If there's a second point moving around, being from my system or from a different system, it's another point that we can triangulate. And it's another accurate distance reading. And that goes up to tens of points. Of course, at a certain moment, if it's too much, then it saturates. But we can easily support multiple systems, each with their own light source that is moving around, and they can even complement each other.
Well, that's a lot of mathematics, and it sounds like that's a lot of code. Are you writing your own code as well, your own software?
We do, yes. So we're a semiconductor company, so we're building silicon. We're building, I don't have one with me now, unfortunately, but we're building what we call evaluation systems. That's the silicon plus the optics plus the compute plus laser light source for people to experiment and develop with. And then we also built software to do the point cloud creation, including calibration, the triangulation, and all the related activities.
So what kind of applications are you providing it just for the industrial robots, the AMRs? Are you also looking at the smart home and the wearable market?
We have a moonshot market, which is AR, spatial computing, Apple Vision Pro alike devices, where we're very aware that it can take a few more years before the killer applications are emerging and before all the devices are really getting to the level like your glasses that are small and elegant enough and comfortable mostly for people to wear them for longer amount of times. On myself, I'm not a believer that that will be the thing we wear for the whole day. I think it will be more like our phone, that we pick it out, we use it for certain applications, experiences, and it goes back. But still, it will need to last more than 2 hours, and it needs to be much smaller as the device today. And so that can take a few more years before that adoption, that consumer adoption also picks up. In parallel, next to that, we're also very interested in the industrial automation and the robotics markets. where we see similar principles that are needed. Power consumption, latency are critical there, and that are, let's say, more established markets. 3D sensing is needed and required there, and it's needed and required today. But those are lower volumes, of course, very different from consumer electronics, but high value opportunities. And so we do both. One hand, the consumer electronics moonshots, and on the other hand, the industrial applications.
How did you get involved in this line of work?
I was gonna say back in 2009, yes, 2009, two of my current co-founders created a spin-off company from the university I was at in 3D sensing, different technology. And so they were running a program, I think it was an entrepreneurship course, where they were looking for people that could help them on the application side and understand, is this 3D sensing technology, which is great from a technology perspective, does it have a merit in a commercial market? And so I jumped in and I did a project for them, and then I joined them as the first employee. And then all the way to 2015, when Sony acquired that company in the time of flight space, different 3D sensing technology as what we do. And then I think I stayed another 2 years and a bit, and then we all kind of left into different ventures, into different activities. I did a stint at an automotive company myself in the Bay Area. But I've always been in touch with those people, and at a certain moment, or we have always been discussing the state of the industry, let's say, what works, what isn't working. And as we continued to discuss and see technology, we realized that what we thought was that the whole industry, or the whole world, would be picking up 3D sensing as part of different type of applications, even toys. You could build fantastic toys with good 3D sensing, but the performance for cost balance was just not right. The power consumption was too high, the cost was too high for the performance that you were getting. And so we realized that, and we also realized we could actually solve that with this technology. And on that imagination, on that virtue, we said, okay, let's build a new company and see where we can get it. And then Voxel Sensors was born in 2020. And then, of course, then you go through all the steps of engineering and market and validation and where's the real product fit or product market fit, and that evolves over time. But we realize now what we can do and what we're good at, and I think we can make a significant impact in the industry.
That's exciting. I love it. And I love to chat with folks who have a passion, and it seems like you enjoy what you do. Like you come to work with a smile on your face. I don't know. Do you feel as I suppose a professional nerd, as a professional geek, and I mean that as a compliment because I'm a professional nerd. What are you most excited about? Is it the moonshot consumer electronics? Like in 10 years, 15 years, what's your prophecy? What do you see this technology being used for that you're just so excited?
I'll answer it in two steps. I think I'd love it to be supporting the spatial computing paradigm. And when we leave maybe our smartphones in our pockets or even at home, and we'll be using wearables to take some of our daily content consumption and application consumption. That would be amazing. When the team and I were at AWE in Santa Clara a few weeks back, we rented a car at the San Francisco airport. It was a BMW, and one of my coworkers asked him, "Hey, can you do a gesture like that? And let's see if it works." And he does, and actually the volume changes. And that's the gesture control of BMW that was in that car. That was what my team developed at SoftKinetic, which was the 3D time-of-flight company I was talking about earlier, back in 2012 to, I think, 2015, when it was first deployed by BMW. And so that moment of what you've worked on, what you've created, what category you've pushed, the gesture control, Apple now has it on the Vision Pro as one of the input modalities for that. But in a car, it didn't exist. back in 2015. And so we pushed it. We've worked day and night to get it out there. And now I rent a car. We rent a car, and it's just there. And it's something you can be really proud of because it's what you've done 8 years ago that you use and you didn't ask for it, right? You just picked a random car and it has that technology, and that's an amazing feeling. So in 10 years, 15 years, if it's in augmented reality glasses with a gesture control and our technology, amazing. But any application that would be using our technology would be a very heartwarming moment, I would say.
I'm thinking in terms of this rapid computing. Do you think this has to do maybe with accessibility as well? And I'm almost thinking in terms of like American Sign Language and so forth, like instant translation. I don't know. I'm trying to think of different applications, and accessibility for some reason just pops into my head.
Yeah, absolutely. There's forgot the name now, and I should give them some credit because what they're doing is amazing. So it's a Belgian company that just moved to New York. And they're actually using sensors on the smartphone to give visually impaired people audio cues of what's in front of them. And so you walk around, okay, the smartphone becomes your perception system, and it tells you what's there and what you need to be careful for. Now that is today very slow and energy consuming because of the sensors and all the processing, but I can imagine that when those low power sensors go into those devices, and when the processing is going to be there, maybe it's going to be a wearable, maybe it's going to be a smartphone, it doesn't matter, but there's a lot to do for the visually impaired people, to help them to navigate the world in a much better or easier way than they can do today.
There's I'm looking right now, actually, I'm searching. We covered, Minneapolis St. Paul at our sister publication, Digital Signage Today, where you can rent AR glasses, and they have a 24/7 staffed line where someone will watch through the glasses and tell you if you have visual impairment, like where to turn, like if you want to go get a snack, okay, you need to go over here. And I'm curious if maybe your technology might be another iteration towards that guided experience.
I've seen it. I've even installed it. I've tried it. You get a picture or you get a snapshot, and you need to describe what it is, right? Yes. Well, the other company, I looked at it while you were searching. It's AYES, so AYES, and it does some of those classifications themselves. I think they do like a crosswalk, a red light or a green light that they can automatically identify and give you then audio cues. Hey, the light's green, you can go, and those kind of things. And of course, as their usage and their database will increase, they'll be able to see more things, recognize more things, more automatically, and give more additional cues to people.
And going back to, I suppose, thinking back to Walter Isaacson, the innovators, sort of the utopianism of the 1960s and 70s space age and the microchip, the idea, and with the internet, leading into the Internet of Things, the idea that technology is designed to unify us and bring us together and make sure that everybody can come experience life together without the divisions, without the limitations. And it feels like the stuff you're working on, and even the technology we just saw on this website, is a step in that direction, which is exciting.
It is. It's absolutely exciting. And while saying that, I think we should also be careful about living in the dystopian world, where it's all digital and it's all virtual and it's all another representation of yourself, like in Ready Player One. Myself, sometimes I drive race cars on a very amateur level, but that's very analog. And some of those cars, like the Polo I'm wearing, it's from another company. It's the classic racing school in France. Amazing team, but they take old Formula Ford cars to circuit, and it's super analog. There's almost no driving aids or anything like that, and it's amazing, and I absolutely love it. So this physical world, which I love, and this digital world, which I also love, I'm not a believer in that will all be transferred into a digital world and live in another reality. But there will be moments where it will bring us together, where we will be really enjoying things in a digital experience with people from all around the world that we might know or might not even know, into amazing experiences. And when we put it away, we go back into our physical world where there's also amazing experiences to have. And so, yeah, and that's, I think, why the connotation or the term metaverse has received or is receiving now this bad connotation, because it's like everybody's going to be in this dystopian digital world and the physical world is going to go away. That I don't believe in, but I strongly believe that we're going to have amazing experiences when we blend those two worlds, and when we have a digital reality, which is going to be amazing, and a physical reality as well.
You're reminding me, I was at the gym and I'm looking at the television and they have an ad for, I think it was Hilton Resorts, and it was so funny, I laughed out loud. They've got the Generation Z girl is with her mother, and her mother has the AR glasses, right? And she's just obsessed with the glasses. She's like, Mom, we got to go outside. We got to do something real. So she takes her to the Hilton Resort, and her mom still thinks she's in the glasses, right? She's like, oh, the waiter, he brought me some wine. It's so realistic, right? You know, it's so high definition out here. And I thought that was kind of a clever way, you know, just to say there's still physical experiences.
There will be, and it will always be. People search for that, and also social physical experiences. There's really a lot of fun. I mean, we see it with home working and in the office working. People go back to the office because policy dictates it, or because they just love to have that social interaction again with coworkers, while you could do it fully remote as well. And some people like to do it fully remote, which is also fine. But I think people are social creatures and will always have that. But this spatial computing world will give us another reality to enjoy that in cases where we can't be physically together for whatever reason, and still want to have something that resembles something close to that. And I think that's great.
Well, Johannes, thank you so much for being so generous with your time. Briefly, do you have any closing burning thoughts that you'd like to shout to the world?
I think I'll link it to this augmented reality world. I think there's a lot of, not a lot, but there's a bit of concerns on privacy, a bit of concerns on meta and metaverse and on our social activities, etc. But if you leave that on a side, and if you think about what's going to be feasible with a spatial computing device that is yours, that you can trust, that is safe to use and stable to use, I think that's going to open up a lot of experiences that we're unable to take today or to experience today. And so I would say to all the naysayers that are, or the non-believers in these applications, to let their concerns behind for a minute and just think about what it can do and what it can bring you. And then we'll, as technology providers, we'll make sure that privacy is there, that the safety is there, that the comfort is there to use it for a longer amount of time. And I'm sure the people on the display side and the people on the processing side and the platform side will do the same in order to bring great experiences to people. Let's work on that all together, and let's give it a few years to get really amazing applications out.